We space lovers can't help but feel a sense of awe whenever we hear about black holes. They are often crowned as the ultimate ruler of the universe. But what if I told you that there is something out there which might just steal the title? Yes, out there in the vast cosmos, something exists that can outshine the black holes with its unique and mysterious influence on the universe. Meet the neutron stars, smaller, stranger, and even more powerful in ways that will leave you speechless. In our last video, we explored the fascinating journey of how neutron stars are born, their mind-boggling density, and their incredible speed. Missed it? No worries, click the I icon above to catch up. Today, we're picking up right where we left off. We'll uncover the role of neutron stars in shaping the universe and dive into the most jaw-dropping cosmic event of all, neutron star mergers. Trust me, this is the ultimate cosmic drama you don't want to miss. Alright, let's get into the real influence of neutron stars. These aren't just cosmic relics sitting in a corner of the universe minding their business. Oh no, they're key players in shaping the very fabric of the cosmos. You could say they're like the directors behind the scenes of a blockbuster movie. Silent but essential. Let's dive into them one by one. Ever wondered where gold, platinum, and other precious metals come from? Spoiler alert, it's not from Earth. These elements are forged in the fiery aftermath of neutron star collisions. When two neutron stars collide, we'll dive deeper into that epic showdown later. But when they do, they unleash a massive explosion called a kilonova. This explosion generates heavy elements that eventually scatter across the universe, making their way into planets, asteroids, and even us. So the gold in your jewelry might have started its journey in a neutron star merger billions of years ago. Next up, the rippling in space-time. You've probably heard of Einstein's theory of general relativity, right? One of its coolest predictions was gravitational waves, ripples in the fabric of space-time itself. Neutron stars play a starring role here. When two of these dense stars orbit each other, their immense gravitational forces distort space-time, creating ripples that travel across the universe at the speed of light. Scientists detected these waves for the first time in 2015, and guess what? Neutron stars were a major source. These waves help us peek into the most extreme environments in the cosmos, revealing secrets about black holes, supernovae, and more. Next, we have the navigational tools of the universe. Pulsars, the super fast spinning neutron stars, aren't just cool to look at, they're also incredibly useful. Their precise clock-like pulses of radiation can act as cosmic GPS signals. In fact, some scientists are working on using pulsars to navigate deep space missions. Imagine a future where spacecraft don't rely on Earth for directions, but instead follow the steady beat of a pulsar. Well, if they do, they can call themselves the space pirates. Neutron stars can influence their surroundings in dramatic ways. Some are found in binary systems paired with another star. Their powerful gravitational pull can strip material from their companion star, creating mesmerizing accretion disks that glow in X-rays. These systems often produce bursts of high-energy radiation, helping scientists study the physics of extreme environments. Neutron stars can even trigger new star formation by compressing nearby gas clouds with their immense gravitational forces. Finally, neutron stars challenge our understanding of physics. Their extreme conditions, insane gravity, ultra-dense cores, and mind-blowing magnetic fields allow scientists to test theories about matter, space, and time. They're like giant cosmic laboratories, pushing the limits of what we know and sparking new discoveries about the universe. So, in short, neutron stars don't just sit around being unique. They actively shape the universe we live in, from creating the building blocks of planets to generating gravitational waves and acting as cosmic navigators. They're essential to understanding how everything around us works. But we are not done yet. We will now dig deep into the most interesting part of this video. Neutron star mergers, collisions that reshape space-time. Trust me, it's the cosmic event you don't want to miss. It's like the universe's version of a grand finale.
complete with fireworks, rippling space-time, and a heavy metal encore. What happens during a merger? Let me set the scene for you. Imagine two neutron stars, each with unimaginable density and insane gravity, locked in a cosmic dance. They are spiraling toward each other, getting closer and closer, faster and faster. Their immense gravitational pull generates ripples in space-time, called gravitational waves. And then, boom, they collide. This isn't just a gentle bump, it's a collision so violent that it releases more energy in a few seconds than our sun will emit in its entire lifetime. The result? A spectacular explosion called a kilonova that lights up the universe, briefly outshining entire galaxies. Yes, if a kilonova happens right now in the farthest corner of our galaxy, right now you can see it through your telescope sitting 100,000 light years away. And the best outcome of this merger is something I already told you at the beginning. It's where some of the universe's heaviest and most valuable elements are born. Gold, platinum, uranium, all forged in the fiery aftermath of neutron star mergers. So, the next time you're wearing gold jewelry, just remember, it probably started its journey billions of years ago in one of these cosmic cataclysms. I know I said that already, but it deserves mentioning again and again. One of the coolest things about neutron star mergers is that they let us listen to the universe. When the stars collide, they send out gravitational waves, ripples in space-time that travel across the cosmos. These waves were first detected in 2017. Wait, did that catch your attention? If it did, congratulations, you're a very attentive listener. Earlier, I mentioned that gravitational waves were first detected in 2015, and that's true, but those waves came from the merger of two black holes. The 2017 detection was groundbreaking because it was the first time we observed gravitational waves from a neutron star merger, an event known as GW 170817. This discovery was made using LIGO, one of the most advanced scientific instruments ever built, along with its European counterpart VIRGO. And it wasn't just a game changer, it was like switching from silent movies to full surround sound. These gravitational waves gave scientists a treasure trove of information: the mass of the stars, the speed of the collision, and even clues about what was left behind: a larger neutron star, or perhaps a black hole. So what's left after the merger? The aftermath of a neutron star merger can result in one of two things: a supermassive neutron star, larger and even more extreme than the original two, or more commonly, a black hole, as the combined mass becomes too great to resist total gravitational collapse. Either way, it's like the ultimate cosmic mic drop. Now, you might be thinking, cool, but why should I care? Here's why. Neutron star mergers help us understand the origins of elements essential to life and the universe. They also give us a glimpse into the fundamental workings of space-time, matter, and energy. These events are like the universe's way of handing us a cheat sheet to its deepest secrets. Neutron star mergers are cosmic events that redefine what we thought was possible. They reshape space-time, create the universe's heaviest elements, and light up the cosmos with breathtaking explosions. Now, before we wrap up, as promised, here are some fun facts and unsolved mystery that make neutron stars the true Iron Man of the cosmos. Did you know the fastest spinning neutron star, PSRJ 1748-2446 rotates at a jaw-dropping 716 times per second. If you stood on its surface, which you wouldn't survive, you'd be moving at nearly 70,000 kilometers per second. That's almost 24% of the speed of light. Move over, Iron Man's suit. This is next level speed. Neutron stars don't just spin, they shine. Pulsars emit light across the electromagnetic spectrum, from radio waves to gamma rays. Some even produce X-ray flashes and gamma ray bursts, making them the ultimate cosmic light show. Neutron stars may be only about 20 kilometers wide, but their mass is mind-boggling, up to 2 times that of the Sun. That's like squeezing a mountain into a marble. Talk about packing a punch. Now let me share some of the most interesting unsolved mysteries about neutron stars scientists are still breaking their heads around. What truly lies at the core? The core of a neutron star is one of the most mysterious places in the universe. Is it made entirely of neutrons, or does it contain something even stranger, like quark matter? Unlocking this mystery could give us new insights into the fundamental building blocks of matter. Some scientists believe that neutron stars could transform into strange stars under extreme pressure, made of strange quarks. These stars would be even more compact and could reveal new physics beyond our current understanding. Magnetars are neutron stars with magnetic fields so strong they can disrupt electronics from millions of miles away. But how do they generate such incredible power? We're still trying to figure that out. Solving this mystery could revolutionize our understanding of magnetism. We've discovered thousands of pulsars, but based on the number of supernovae, there should be millions. So where are they hiding? Could they be cloaked by interstellar dust, or are we just not looking in the right way? The hunt continues. Neutron stars are the universe's ultimate paradox. Tiny but incredibly powerful, mysterious but enlightening. They push the boundaries of physics, create the building blocks of life, and light up the cosmos with their energy. In the grand scheme of things, neutron stars are the unsung heroes of the universe, small but mighty, just like Iron Man. So, the next time you look up at the stars, remember that somewhere out there, these tiny cosmic titans are spinning, glowing, and reshaping the universe. If you enjoyed this journey, don't forget to like, comment, and subscribe. See you in the next cosmic adventure.